Hi, so I made this fun little project with the new simulation nodes in Blender 3.6, and I thought I'd share a bit of the process. I'm using the new quick fur for the new curves object, but you can use whatever grass system you make as long as it's made with curves. So for the simulation, I'm going to add a new geometry nodes modifier, create a new node tree, and go to the geometry nodes workspace. To control the effect, I'm going to use an empty. So let's add an empty. I'll use a sphere and set its radius to something like 0.1, something like that. Then bring this empty to the node tree. And basically what I want to do to begin with is to trim all the curves that are close to this empty. So to find out which ones are close, I'm going to get the distance between the empty location and the position of each curve. And to get the position of each curve, I'm going to evaluate the position on the spline domain. So let's add an evaluate on domain node. Let's choose spline domain and let's feed this the position. Okay, so I want to give a different treatment to the curves that are outside of this radius from that one of the curves that are inside of this radius. So for that, I'm going to use a greater than compare node, and the ones that are whose distance to the empty is more than this value, I'm going to separate them to treat them differently, like I said. So let's use a separate geometry and plug this here. So now you can see we have the selection contains the curves that are outside of this radius, and the inverted contains the ones that are inside. So now for the ones close to the empty, I want to split them between the root that is going to keep connected to the ground and the tip that is going to be cut and eventually fly out. So I could do this in a couple of different ways. One would be to use another separate geometry node, and for the selection use the factor of the curves, but I found it actually was faster, at least in my experience, to use a trim curve node. So I'm going to actually a couple of trim curves, because I want to have the trim from 0 to the cut length, and then also the trim from the cut length to the end of the curve. So let's use a value node to provide the cut length for both nodes. Let's put something like 0.2, something like that, and plug this to the start. So we have from 0 to cut length and from cut length to the end. So let's see this. Like you see, this is the root of the grasses and this is the tip. So let's join all of this together for the time being. Like this, and in order to visualize what is happening, and also because we're going to need this for later, I'm going to rotate the cut hairs so they are parallel to the ground. And to do that, I'm going to use a set position node, and for the position I'm going to use the position of each point of the curve rotated around the position of each curve. So let me show you what that means. I'm going to use a vector rotate node, and I'm going to rotate the position, like I said, position around the same position but evaluated on the spline domain, so we get the position of each curve. So something like this, and I'm going to rotate it along the X or the Y axis. Let's use the Y axis, 90 degrees. So now you see wherever the empty is, and let's lock the C location of the empty so it's easier to move it around, keeping it on the floor. Wherever the empty is, the grass gets cut and the cut part gets rotated to be parallel to the ground. Okay, so let's add a simulation so that this effect is accumulated, so that when we move the empty, the grass that is already cut remains cut. For that, I'm going to use a simulation zone, and I want to bring all of this inside the simulation. So let's cut this here, let's cut this, and actually I don't want to showing this inside of the simulation. I want to keep them separate inside of the simulation. So for the selection, I'm going to plug it here, and I'll call this uncut grass. And then for the grass that it's cut, the roots of the grass, I'm going to add another simulation state and call it short grass. And for the one that's been cut, let's add a cut grass state, and I want to accumulate the short grass and the cut grass, so I'm going to join the previously short grass with the newly short grass, and the previously cut grass with the newly short grass, like this. So now if we join all of these states outside of the simulation, if we hit play, we can see that now the grass gets accumulated. When we move the empty around, we keep cutting more and more grass. Nice. So now let's add the physics, the movement to the cut grass. For that, I'm going to add an initial speed as an attribute to the newly cut grass. It's going to be a vector called speed, and for the time being, let's add just some vertical speed, and I'm going to use the speed to move the grasses with a set position node. So the offset is going to be the named attribute speed. So let's see what that looks like. Okay, it's flying upwards. So now let's add some gravity, so the grass shoots upward, but it's always accelerated downwards, so it falls. And for that, I'm going to be updating the speed by adding a negative value on the z-axis on each iteration. So let's say something 0.03, maybe something like that, and store this updated version here. So let's see, now it goes up, but then it falls down. Nice. And I want it to hit the ground. Now I don't care in this case about the direction it hits or anything like that. The floor is just a plane, so I'm not going to be using any ray casting or anything like that. I'm just going to compare the Z position of the grass to Z equals 0 and make it stop if that's the case. So when I update the speed, I'm going to use a switch node to have a conditional behavior, such that if the condition is false, the speed gets updated by adding this acceleration like before, but when the condition is true, the speed gets set to 0 like this. So let's create that condition, and that condition is going to be z equals 0, or is less than or equals to 0. So less than or equal to 0 is going to be a float, and I'm going to take the z coordinates of the position, but updated by adding one, like the next iteration, so it doesn't go through the floor, but it stops before going through. So the position of this iteration plus the speed, which would be the next position, if that is less than or equal to 0, then the speed is going to be set to 0. So let's try this. Now I want to change the direction that the grass is shoot on. So instead of being purely vertical, purely upwards, it's also backwards, so in the opposite direction to that one in which we are moving the empty. And it's a good time to also bring the mower to the scene, because we're going to use that same direction to orient the mower as we move the empty around. So I have a mower model here in this collection, and I'm going to bring this here as a node. I'm going to set its position to be the same as this empty position, and I'm going to use a different showing geometry. Here I could use the same one, but for dealing with materials and those kinds of things, it's better to have this step where you have all of the grass together as one geometry and the mower in another. So I can add a set material node here, for example. It doesn't really matter for the time being. So now the position of the mower is always tied to the empty, but the orientation is not. So to get the direction of the movement of the empty, I'm going to compare at each frame the previous location of the empty with the current one, and for that I'm going to add the location of the empty as a simulation state, like this, and now I can compare it by subtracting, well, let's actually give it a name, radius empty log. Well, it's a bit long, but whatever. So now I can compare it by subtracting the previous one and the current one, and we can output this and use this. It's going to be a direction. Use this to orient the instance. So for that I'm going to use a rotate instances node, and I'm going to transform this vector into a rotation. So align Euler to vector and plug this rotation here. So now the mower gets oriented according to the movement, but not in the direction we want. So let's try with the y-axis, and now it is correct. It's a bit jittery because, of course, from one frame to another our movement with the mouse isn't very stable. If we wanted to make it more stable, we could keep passing the location of the empty to new simulation states. So from previous log to previous log 1 to previous log 2 and stuff like that, to keep like references to, let's say, the last 5 locations of the empty, and then perform some math on that, some linear regression or something like that, to get kind of the average direction of the last 5 frames, for example. But I don't think this is that bad, so I'll leave it like this. And now I'm going to use this same direction to orient the grass so that it is shot backwards instead of just upwards. And for that, here where we create the initial speed, where is it? Here. We are going to use a combine XYZ. For the Z direction, I'm going to give it a bit of a different treatment, but for the X and the Y, I want it to be oriented like around this vector, but with some randomness. So I'm going to add a random value, make it a vector, and like I said, for the C, I'm going to treat it differently, so I'm going to separate this and map range to the values we want for the C direction, so maybe from 0.07 to 0.12, something like that. And for the X and Y values, I'm going to take this direction, normalize it, because I don't care how much the empty was moved between one frame to the other, I just care about the direction. So let's use a vector scale node, and I'm going to randomize this value, and this is going to randomize the strength along the direction of the mower movement. But then I also want to randomize the direction itself a bit, so I'm going to add this random vector, also scale down to be able to control how much randomization we want. And we're going to add this, and then I'm going to separate the XYZ, and we're going to disregard the C direction from all of these and just take the one we already set up here. So I'm going to just plug the X and Y coordinates here, and this is, let's try some values. I want the main movement to be in this direction, so for example if we put 0.1 here, this one's going to be quite lower so that it's not that random. Let's try it, and then we can play with those values till we find, oh, and as you see, this is quite crazy, but this is because the random value is being randomized per point and we want it per curve. So for that I'm going to again use the evaluate on domain, but this time evaluate the index and use this as the ID here, so the randomization is per curve, like this. Let's open another 3D view editor to see this better. Okay, and it's working fine. Now it's just a matter of tweaking these values to get the kind of effect we want. We could also add dynamic rotation to the cut grass by doing something very similar to what we did with the position, but I'm not going to get into that here. If you have any questions or comments, please leave them below, and I hope you found this useful. Thanks for watching.